Our next speaker is derived coming from the University of Florida.
Okay, testing. Can everyone hear me? There we go. All right. Hi, everyone. My name is derived, and I'll be presenting my project I did with Dr. Nestor Espinosa on building a treasure detector, a quick look pipeline for JWST, NIRISS, FGS guide star data. So let's start off. Right off the bat, what is FGS? FGS is the fine guidance sensor, and it uses guide stars to keep the JWST on track. So this essentially means that the FGS locks onto a guide star, and over time, if the guide star shifts out of the frame, as you can see in the plot I generated here, the telescope would try to correct for that and keep the guide star stable. So this is very important because without these high precision and pointing of the guide star, we won't be able to get high quality photos for the science data that we get from JWST, or have any photos at all, or any type of science observations without this pointing. So the FGS sends this data to the altitude control system, ACS. And what that does is that actually moves the observatory left or right, or wherever it needs to go to have a great pointing on the guide star. So another quick tidbit about the FGS is that it's within the 0.6 to 5 micron wavelength range, and it also have 2 guided channels. So we have all of this different data from different program IDs that we get from JWST. Every single program ID has this guide star data, but it's not really explored for science. It's mostly unexplored for science. So let's take a quick look at one of the implications for this. So this is an exoplanet transit taken from NIRSPEC, and you can see here it's a regular transit, but at this point here, the actual transit just shifts downwards. This is not part of the science data. This is something that's systematic and needs to be corrected for. And studying the guide star data can actually help us with this. So the question is, how can we design a pipeline to download and analyze guide star data from MAST for all accessible program IDs? So this is where the project I've been working on comes into place. And it's called Spelunker. So what Spelunker does is it gives you a wide range of different tools that you can use to download this data from MAST and get you tools to analyze that data and to also additionally see exactly what kind of technical anomalies it is in the data, as well as potential stellar properties of the actual guide star itself. So let's jump right into this. So one of the main packages, one of the main functions is something called Spelunker.load. So you input your own program ID along with the observation number and visit ID. And what it basically does, it loads it all into one object, and you can call out any object you want. So let's say if you want to plot a quick time series, you can use spk.time or spk.flux, use both of them, and plot a time series of the guide star data just by loading it in. So after that, there's more things you can do with just the guide star data. So with each of the frames, you can fit 2D Gaussians to each of the frames to get more out of your guide star data. So this includes things like the offset, which is the counts for the background, the amplitude of each of the Gaussians. So this is the counts for the exact position of the guide star data, as well as things like the centroids, the standard deviation, the width of the guide star, which can correlate to the PSF changes, as well as the orientation. So using parallel processing, we can fit around 100,000 FGS frames in just minutes using parallel processing with a package called Ray. So after we fit all of these Gaussian parameters, we could do a lot more with it as well. So we can do things like do periodograms to the Gaussian data. So let's take a quick look at that. So using, this is a time series of the X centroids from the Gaussians that we just fitted. And you can kind of see there's some kind of oscillation here, like there's a sinusoidal pattern. So with the periodograms, you can easily look at this frequency or the period, and with the large array of data, you can quickly look at what kind of periodicities are in your data sets with any Gaussian parameter. You can also create animations too. So there's a wide variety of different animations you can create. This is just to showcase some of the little weird quirks that happens with guide star data. So let's just zoom into one of them. So over time, you can see that this guide star, as the time increases, the guide star just changes in PSF. The PSF just widens, and over time, it'll gather itself back up. So this is just to showcase how animation is going to give us a little bit more information on how guide stars can act spatially. Let's jump into the next one. So this function is something I created to visualize the exact guide stars that we use. So within the given program ID, there could be one or multiple guide stars that is used in that same program. So using something called spk.guidestarplot, we can easily plot exactly what guide stars are being used. And we can reference it across a reference stars using something called astroplanet. And we can be able to easily visualize the location as well as the track over time to see which exact guide star that is being tracked over time. So let's take a quick look at the science implications here. So do you remember this transit here? So this is that exact same transit from before, from NIRISS of WASP 39b. And at that exact point, or at around 5 hours, you can see that there is, when we overplot the guide star data on top of that, so the guide star for the x width of the Gaussian fits we just fitted, we can see that there is the exact same event that happens there. So this is very important because we can use this to correct for our science data just by using another data set for the guide stars. And this is available for all the different program IDs. So this could be related to something called a tilt event, where the James Webb Space Telescope mirrors just kind of snaps at randomly due to a dispersive energy. So there's other things we can do with this as well, such as light curve detection and comparison. So this is another exoplanet transient. This is just some of the flux, the light curve for one of them. And you can see that over time, there's this little curve and dip. So you can overplot that with the guide star data. And the guide star data actually has that same dip too. So this is not part of the science. This is something systematic. So we can also use the guide star to correct science target flux time series as well. So some of the work I developed, so I developed a package called Spelunker, utilized object-oriented programming to do so. I also employed MASS and JWST APIs within the packages, and I additionally performed analysis on FGS time series data by using the package I created. And also for future work, I hope to conduct an automated search to explore stellar activity and to find, stellar activity using the guide star program I created, and also to find exoplanets, continue improving on the package with bug fixes and replying to issues, and also advertise the package to conferences like AAS. And maybe even a little bit, create images like this, because it would be really cool. So, and this is the link to the GitHub. It's available right now. You can install it just by using pip install Spelunker. And thank you so much for listening to my talk, and here's my acknowledgments. I'd like to thank Dr. Espinosa, Carolyn, and the SAS, STS, CI, and NAC as well. So thank you. So I'd like to take any questions. Yeah.
Great presentation, by the way. So you mentioned about mechanical anomalies, such as like a tilting of the mirror and the James Webb. So how can you distinguish the kind of like anomaly from each other?
Yeah, so that's a great question, actually, because I do have an extra slide for that somewhere. So this is another tool I created called mnemonics. And what it does is you can overplot different technical mnemonics from the JWST, such as high gain attentive movement, and additionally things like the NIRISS filter wheel movement as well. If there's any current, you can kind of see, if you can overplot it on top of whatever time series that you create with Spelunker. So here, there's some kind of dip here that occurs right around where the filter wheel will move. And there's also high gain attentive movement. So that's the attentive movement is basically where there's an antenna on the JWST that communicates with Earth, and that moves every so often. So you can overplot on top of your data to see if there's any anomalies like that.
So it looks like tilt events always happen during planet transits. That's a constant of JWST, I don't know, motion. Anyway, but I was wondering if you think this can be really useful, like the plot that you showed with weird guide star time series. Those are worth analyzing per se, even without the science, to see if they, if we find out more tilt events, more meteoroid hits and things like that. I don't know if you guys are, gonna do that, but I think that per se is already super interesting. So this, are those data public with the mnemonics and not mnemonics, the telemetry and FGS data, or they are proprietary with the program ID? Like, Yes.
So for the mnemonics, the way how this works is that you need to input your own mass API, own mass API token. So you can specify that within the Spelunker.load function. There's multiple parameters. There's even on the GitHub there is more. There's more ways to do that, but to basically for mnemonics and other things as well. Certain other functions, you'll need to input your own mass token, so you can be able to access the mnemonics as well. And let's say if you have any exclusive rights for your own program ID, you should be able to do that now when you download it. So if you input your own token, you can access your own data that way.
Thank you so much for the talk and the amazing work. I absolutely love it. I just started and I become the second star on your GitHub page for this repo. And I'm just wondering, so you made this specifically for Web's guide star thing, but do you think it could work for any other thing? Like maybe, I don't know if HST also has publicly available guide star, or maybe other telescopes that people have.
I actually had this same question from the NIRCam branch meeting I attended to, and I do believe that this code can do that for sure. And if it somehow doesn't, I'll be able to make that happen. So all I need to do is make sure to find the actual Hubble Space Telescope guide star data, and we can work with that. So that's something that's 100% a possibility, and something that I'm heavily considering too.
Oh man, I actually have two. So I'm intrigued by the potential of the create images like this. You have a wonderful way of identifying when you have impacts to FGS data, but you have is it at a point now where you can correct for those issues, or is it just still we know that there was an impact here, or we know that there was a mirror tilt event here. We just have to live with it, sort of thing.
Yes, so within the 2 months, I was able to create the package to actually access the data and have it readily available for you to use. There can be additional features to, let's say if you have an input of your own data, like for a time series, there could be some software that can correct it automatically. So far I have not implemented that yet, but I was actually considering that recently too, because that would be very helpful to just put in your own data sets within put it into Spelunker, and what it does, it would like automatically correct for those anomalies. So that's not something that's not yet feature, but that's something that's amazing. So that's a great suggestion for
Looking
sure.
forward to. The second question is online, and it's why such a creative cave diving related name to your package?
That is a great question. That is because if I go all the way back to the first slide, my mentor gave me the title of building a treasure detector. So, and what a pipeline does, it basically kind of just mines for your data. So Spelunker is a term to kind of go into like caves and mine for different ores and different treasures and things like that. So I thought this is like the only name I can give it. And it's also cool. It's a cool name. So yeah.